Welcome back. We're going to do a little bit more with mathematics and expressions. Hopefully you've had some experience with algebra and those kinds of mathematical forms throughout your careers in schools. But we're going to talk a little bit in this case of how do I calculate something like the area of a circle, which if we look at it, that's basically the radius squared times pi. Well, we don't have a radius, so we need to get the radius. Then we're going to calculate the area with the formula, and then we're going to display the area to our happy little computer. My cat helped me on that one. So let's get the radius. To get the radius, we need to ask for it. And we'll go back and make sure we leave a little space for someone to enter something in. And then a reminder, standard Cin. And now we have both the radius set up for us, and we know the formula to an extent, but to calculate the area is your radius raised to the power of 2 times pi. You'll notice I've already got pi set up in here as a constant double and all caps as a reminder, and set it up at 3.14159, which is good enough for our approximation. And this is the formula that we normally get, which brings into the concept of the question of what is the order of operations for these things, and how do I actually do something with a square. Mathematical symbology aside, C++ does not have anything to do with powers. We can't do them. They don't exist. So for us to do that equation, we need to use a couple of things. But when we start talking about this, if it was a real equation, if you've all seen all the stupid, Facebook and Instagram and whatever, what's the answer to this problem? And they show multiplications and divisions. We have the order of operations that's standard. If we flip over here to c++.com or c++reference.com, they've got a little description of all of the order precedence of operations and all the things that fall into that. If we go all the way down here to 5, you'll see that multiplication, division, and modulus, multiplication, division, and remainder, are left to right order of operation precedence. So if you come across multiplication, division, and modulus, you'll see them happening first. Operation in order number 6 is plus or minus, which is addition and subtraction. There are a whole lot of other operators here that we have. And if you look way up here, the very first operator is our scope resolution operator. So that means that standard : the scope resolution operator always happens first, because if you didn't, you wouldn't know where to go find things. And there's a whole lot of other things that are in here that we'll get to later on. So what we see here is we don't have a POW. We don't have a power. We have something called POW. And in C++, that would be POW. Now, POW is an interesting thing. It has actually some certain rules to it. You've got to give it a few things. And actually, let's see what they've got for us here. Or no, maybe not. Okay. So power gives us the ability to take a number and then raise it to a power. In this case, we wanted to take the radius and raise it to the power of 2. And that will generate for us an answer. Now, we don't really have a POW because we don't really have it as part of IOStream. What we have, though, is a library that is a system library called cmath. You may see things like this in your exploration around the net. This is a C library. This is the C++ library. So typically, 90% of the time, you're not going to use a .h library. You're going to use the cmath library. And then, once again, we have to tell it what all this is. So, area equals POW times pi. And that looks, well, I don't know. Oh, this is a new feature, by the way. This putting things in front of it to tell you what exactly it's supposed to be. We'll just ignore it for now. It's a feature of the IDE. But there's your radius, there's your number, and now let's output it. and try to compile. It wants the radius. Woo! So we'll give it a radius of 10. And the area is 314. Now this is an interesting question for you. To think back, I think we talked about this. If not, we will now. 10 raised to the power of 2 is 100. 100 times 3.14159 should be 314.59. What happened to the 0.59? Questions. The problem with this is something called an integer area. Integer area, even this is a double. There's lots of things going on here. For example, pi is of type double. Area and radius are of type integer. In this case, we'll kind of make the assumption that the ability to generate a power generates a number, and let's pretend like it actually returns an integer. In C++, implicit conversion says, oh, I have a double over here, 3.14159. Therefore, to make this math precise, I'm going to make both sides of the multiplication have the equivalent precision. And it drops this, poof, magically into a double. So it does a double times a double, which gives you a double. However, it stores it in area. Area being an integer means that this result of double is truncated. Anything after the decimal point, in this case here, the 0.59, is truncated away, which gives us only 314. That's all we end up with. So if we want this equation to be more precise, we have to change the resulting storage mechanism, area, and probably also change radius to be more precise too. In the old school POW implementations, both of these had to be doubles or floats. So what's happening actually inside here is it's saying, oh, you gave me an integer, I can convert it to a float. You gave me an integer, I can convert it to a float. So it does that on the fly. They may have implemented an int, but I haven't seen it in the documentation. So let's fix this a little bit. Let's take the double and turn it into doubles. And now, without changing anything else, we're going to enter the same value. Let's see what happens. And there we go. 314.159. Magic. So now we've treated the doubles as doubles. We don't have to do any implicit conversion, and the operation is all happening. Now, if we added more math in here, pretend like this has any meaning, and we did this division, remember your order of operations. It's going to happen left to right, multiplication then division. So if you wanted the result of this part of the formula to be divided by 3.3, you have to use good old parentheses. And you may have heard the old expression PEMDAS. So the parentheses says parentheses go first, multiplication, division, addition, subtraction. So, and modulus is in the middle. So modulus, multiplication, addition, subtraction, in the order that you saw that before on the website. So this would say, do all this, then divide it by 0.33. Has no bearing whatsoever on the formula. It doesn't mean anything. Just showing you that if you need to do algebraic type equations, make sure you surround the appropriate parts with parentheses so that you get the results of what you wanted. So if you had something like this, instead of getting all of this divided by 3.33 times 2, if that was what you wanted, you would need to come in and apply the appropriate parentheses to this. So just remember, parentheses help you group equations. For large equations, it might actually be worthwhile to have intermediate answers and then do the math to make sure you're doing it correctly, because the longer this equation gets, the harder it is to debug. Anyway, that's an introduction briefly to order of operations and a little bit about the math library. There are tons of things in the math library, but this is just one of them. Hope you're having a good day.